this video, we're going to explain various things about the Möbius strip. And we're just going to start with this sort of picture here. So this shows a Möbius strip embedded as a subspace of R3. We want to explain a bit more about the geometry of this. Okay, so we made this Möbius strip by kind of starting with the disk, as shown here. A disk with a kind of red circle, and across the red circle we've got this blue line, a blue diameter. And what we want to do is to rotate the disk around the z-axis, like so. And as we rotate around the z-axis, the blue line is sweeping out the Möbius strip. But a kind of key point about how this works is that the blue line is rotating kind of more slowly than the disk is. Okay, so here we've got the disk over here, and then we're going to take the disk around through an angle of pi, or a half turn. Okay, so it's a half turn from here to here, and over here, you know, the blue line is like horizontal, and now we go around here. We've done a half turn of the disk, but the blue line now is just turned from being horizontal to being vertical, so it's turned through a right angle. In other words, a pi over 2. So the disk has gone around through pi, and but the blue line's only rotated through pi over 2. And now we carry on around. Now the disk is rotated through a full 2 pi, but the blue line's only rotated through an angle of pi. But that doesn't kind of matter, because we're just looking at the blue line as a line. It doesn't have any direction to it that's important. So if you take a line and you rotate it around through a half turn, then you've still got the same line. So that's kind of the key point about what's happening here. The blue line is only rotating at half the speed that the disk is, but that doesn't matter, because turning the blue line through pi leaves it back exactly where it was. And as we do this, the blue line sweeps out the Möbius strip. Now we're going to discuss another way we can build a Möbius strip. Okay, we can start with an annulus like this. Okay, so we've got kind of a big disk with a middle disk cut out, but we've marked the boundary of this annulus with 2 colors. So this section around here is marked green, and then this section here is marked red. What we're going to do is we're going to glue points on the outer edge of the annulus to their opposite points. So this point here with the blue and the green meet is going to get glued to this point over here with the blue and the green meet. And if we look at this little section here, just going around there, then that's going to get glued to this little section over here that's opposite it. So these green points here get glued to these red points here, and as we carry on further around, all these green points here get glued onto these red points around here. So in general, the whole of this kind of red arc is going to get glued onto the green arc. And as we try and do that, we're going to find that we need to do some. The annulus will have to temporarily cross over itself in order to make everything fit. But we can visualize this by just sliding the slider, and then so far it's still kind of all properly embedded. But as we come along here, then we have to sort of make the thing intersect itself as we try and move this green arc around so that it can glue onto this red arc that it's supposed to glue to. We carry on like that. So now we've kind of twisted it around a bit, and everything's sort of lining up so that things can glue on where they're supposed to glue on. And there we are. Now we've got a Möbius strip. So that's another way we can think about the geometry of how this is constructed. One other thing that we want to discuss about the Möbius strip is what's its homotopy type. So it turns out to be quite simple. I mean, the sort of twisted band nature doesn't affect the homotopy type at all. Around the middle of the Möbius strip, we've got this kind of core circle, and we can just push everything down onto that core circle like this. And in terms of our first construction, we swept this blue line swept around the z-axis whilst turning, and that swept out the Möbius strip. And if you look at the center point on the blue line, that will trace out this red circle here. And what we're doing in this homotopy is, kind of each stage we're just shrinking the blue line down to its central point. And that squeezes the Möbius strip down onto the circle. And our conclusion is that the Möbius strip is homotopy equivalent to the circle, or in fact the inclusion of this core circle in the Möbius strip is a homotopy equivalence.